Hey everybody, welcome back. We're in the middle of our lesson on geometric series. Sorry about that, my internet cut out in the middle of the lesson. We are on example 2. We're talking about finding the sum from n equals 1 to infinity of this expression. And we had our first term equal 4 and our common ratio as 1/4, and now we're using this formula, a1 over 1 minus r. So we've got 1 minus 1/4. And all we've got to do is simplify. We can turn this into 4/4, so 4 minus 1 is 3/4. And if we multiply by the reciprocal, we get 16 over 3. We can use our calculator to check this. I'm going to go into math and summation. And I'm going to choose the variable k. It really doesn't matter what variable you use. K equals 1, 2. Well, we can't put infinity into our calculator, but we can use a big number. I'm going to use 1,000. If you use a really, really huge number, your calculator is thinking about computing a sum of a huge number of terms, and it might give you the spinning wheel of death and scroll forever. But 1,000, let's see if that's a reasonable number for a calculator to use. 4 times 1/4 raised to the power, raised to the power of k minus 1. So I'm going to hit alpha k minus 1. I've got the spinning wheel of death going on. It's calculating all of those terms, plugging in k equals 1 and k equals 2 and k equals 3 all the way up to 1,000 and adding them together. We get 5.33333. Let's check, is that equal to 16/3? Yes, it is. So we know that we found our correct solution. Here's another example. In part B, we want to find the sum from k equals 1 to infinity of 3 times 5/3 to the k minus 1. Let's think about the meaning of that. If we were to plug in 1, we have the value of this being 1 times 3. If we plug in 2, we have 3 times 5/3 raised to the first power. If we plug in 3, we have 5/3 squared. Well, since 5/3 is a number greater than 1, every time we raise the exponent to the next power, the value of this gets bigger and bigger and bigger. So since the value of this gets bigger and bigger and bigger, we're adding all of those terms together. That sum is just going to increase infinitely. So this is a case where we cannot find the sum. We would say the sum does not exist, or that it approaches infinity. And here's our last example. We're asked to find 5 plus 0.5 plus 0.05 plus 0.005 plus ... Those 3 dots imply that we're going to continue this pattern to infinity. So we want to find this pattern, we want to find this sum to infinity. Well, let's think about our formula, a1 over 1 minus r. The first term is 5. And the common ratio, well, if we think about the pattern, to go from 5 to 0.5, we're multiplying by 1/10. And to go from 0.5 to 0.05, again, we're multiplying by 1/10. So 1/10 is our common ratio. 1 minus 1/10. So we can think about 1 equaling 10/10. 10 minus 1 is 9, 9/10. And then if we multiply by the reciprocal, we get 50/9 as our sum. That's it for our lesson on geometric series. Thanks for watching.